Hello, everyone. Good morning, good afternoon for people seeing us outside the US and Europe and MEA. I am Valentin Malave, Business Development Manager at RIEGL USA. I am seeing people still joining us. Okay, so thank you all for joining me today on this webinar about how data collection workflows can be improved by utilizing different approaches and methods other than the conventional ones, in leveraging the advanced features of our systems to collect better and faster. On the agenda today, we are going to be talking a little bit about RIEGL history, the TLS the TLS overview, a couple of, the webinar highlights about works matter, not longer, get it right the first time, simplified setups, the survey control is key, georeferencing made simple, go quicker, go mobile, and a couple of conclusions, and of course, opening the floor for a Q&A session. Okay, so a little bit of RIEGL history. RIEGL is a global leader in the manufacturing of laser measurement systems. The company headquarters is in Horn, Austria, and it has been in business for more than 40 years with offices worldwide. In North America, we've been delivering cutting-edge laser scanning solutions for over 30 years now, providing a very wide range of sensors, integrations, and turnkey solutions, including terrestrial, industrial, mobile, airborne, bathymetrics, and UAVs, including hardware and their corresponding software for data acquisition and processing. Our industry and clients have known us for bringing the highest performance, quality, reliability, and longevity of products. This is our terrestrial division, the one we're going to be focused on today. We offer 5 systems over here. So the most versatile one is going to be the RIEGL VC600i. We also have the RIEGL VC400i. It's very rugged and robust with an aluminum case for the harshest conditions. We also have the long-range VC2000i with up to 2.5 kilometers in range. That's over 8,000 feet. The newer version of the VC4000i just recently released. It's faster and even easier to use than ever. And we also have the unrivaled VC6000 scanning glaciers in open pit mines, even in dust, haze, rain, and snowing conditions. All of our sensors are time of flight, meaning that they measure the time of a pole of laser light travels from its origin to an endpoint and comes back, recording multiple returns with the highest accuracy and lower noise range. Our systems have several options for data acquisition, like selectable pulse repetition rate, where you can select the range, distance to scan, make different measurement programs to choose from different point densities at a given range. They are all multi-target capacity, meaning that they have great penetrating capabilities, such as on vegetation or through flying particles in the air. And we also have a great and extensive portfolio of accessories that includes external cameras, RTK antennas, different mounts, and even a robotic system for remote scanning. So my focus today is going to be on the VC600i, the 25-second scanner. It's the most versatile one. It's amazing. It's compact and lightweight. It's incredibly fast, accurate, and reliable for indoors, outdoors, short or long range. It is easy to use with a single button. It scans simultaneously LiDAR and image acquisition that will help you collect top quality data in a fraction of the time you're used to. This scanner is unparalleled in speed and density. At 6 millimeter at 10 meter range, or an eighth of an inch at a 32-foot distance, one single scan position delivers a point cloud of over 30 million points or measurements on the 2200 kilohertz program, right? So that is that it can measure per second 2.2 million times. It's the results are very crisp, and it will deliver a very point cloud. It also has a real-time onboard automatic registration, meaning that the scanner has two powerful processing units inside, one for the data acquisition, and the other one is for registering all your sequential scans on a cloud-to-cloud base. Once you finish your project, you'll have a fully registered point cloud. The VC600i has the power to transform your project's timeline. It is user-friendly. You can see it has a 7-inch touch screen where you can scroll up and down just like your smartphone, and tap on the apps and scan with a simple touch of one button. So going back to our agenda, or our business today is we're going to be discussing the points mentioned, right? So I will go over the typical situations that affect the data acquisition in each of these topics described, and feel free to add your questions to go over them later in the Q&A section. So work smarter, not longer. I'm going to share two projects that are very different in scope and requirements. The first one is about a wide open area that needs a scan to record a precise location of assets such as building, easements, trees, and such for permitting and for future design of improvements. And the second one, it's one that needed to follow a path of specific pipelines hanging on the ceiling of a very complex environment, a small room, let's say. And the objective of that project was to document as-built and for design and engineering for retrofitting new pipes and service lines. So on data acquisition, we know it's a time-consuming process. So speed does matter, and actually it matters a lot. You know, you have probably spent long hours just waiting for the scan to complete, and then the images, and then all that adds up like a snowball going down the hill, because scan projects require multiple setups. You need to drastically reduce that time lapse. It's natural evolution. It's I'm showing on here using a fax modem like the picture I just put over here, because you wouldn't even be here in the webinar, right? So we all want fast connection, fast turnarounds, faster results all the time. So why not a faster scanner? Why not improve and evolve, right? The bottom line is that you need to complete your projects fast, efficiently, and deliver the highest quality product. That is why you got hired. That is why you need to. That is what you need to do, because you are a professional. So, what are some typical pain points in scanning project workflows? Long hours in the field collecting data. We briefly touched on that. Dual cycle on data and images. So that's scanning, going once for scanning and then again for images. The lack of flexibility on the workflows. Lack of capabilities on the hardware, for example, limited range or stringent parameters on the scanner. The VC600i improves in all dimensions. You don't need to level it. You can just set it as in this image and this picture over here. You can just like take it out of the tripod and just put it on a stairway just like this. It doesn't need you don't need to level it. It has double AMU that compensates orientation and inclination. And as long as you put it on a stable surface, and then you can just scan right there and there. So you set up your scanning is just one scan position after the next one. So after it completes the scan, it will show you a preview. Let me show it over here. It will show a preview of the scan and the images, allowing you to check and QA/QC your data, either on the 7-inch screen on the scanner or connecting through the app on your smartphone, tablet, or laptop. Let's talk a little bit about the automation of the workflow. speed up the scanning process. You can select the workflow over here, the measurement program. First, you would select your pulse repetition rate. That's the distancing range you need for your scanner project. Then you would go to the scan pattern over here. That dictates the density or the point distance at a given range. It's also known as panorama, as you can see. And you can create your own. And after that, it's just scanning. That's it. You just start your scan and let the scanner register the rest of your scans with a real-time onboard automatic registration. So you can have different projects that are very different in scope and requirement. And here are the two examples that I was just mentioning. Two very different environments and different outcomes. For the first one, we have these 11,200 square feet lot with 25 setups. It took me like 35 minutes to scan the whole area. Now, in this one, we needed to follow a path of pipelines underneath the ceiling for us build and the design of future retrofitting of pipes in this complex environment. So you can see here, both results are very impressive. The point clouds are very neat, very crisp. You can see all the details, and actually you can do some like layering of the data, so you can actually see the whole ceiling and the pipe that you want to follow the route, right? So for this area, that was like 90 square feet, 900, with 28 setups in about 25 minutes. So the point here is that you need to be fast and nimble. So same as your tools, the faster scan just doesn't save time. It also enhances productivity, reduces your costs, and allows teams to complete projects faster, improving profits and scalability. So who doesn't want that, right? Okay, second item is the get it right the first time. We need to work efficiently, so we have one shot, and that's all we need to deliver a successful project. So one of the biggest hurdles in performing QA/QC in the field, and it's very much needed, it's in fact that, and actually, in fact, it should be mandatory in other projects. We need to eliminate all the guesswork while scanning. We need to make sure a project is completed with all needed areas covered and even more, right? We've seen how in many occasions going back to the site is not possible, and we do not want to go through an embarrassment of informing our clients that we missed some data, that we messed up, or even worse, we did not collect some areas on the first run, right? So that's why we need first, our first checking method is the preview of the scan right over here. And once you finish your first scan, you can actually see, you can create a high resolution preview and see it back again and see that all your areas and all your environment has been scanned right. You can see actually the images as well, and click on the images and see if you have the right images, the right angles, and then you go to the second scan, right? After that, you can just go into you can check on the registration, so you can see that it's going sequentially on top of the scanners that you just did. So if you're on scan 44, that this most probably will show, scan 43, because it goes sequential, right? You need to scan and complete the first the scan to be able to process it on the background. So if it's green, it means it's good. If it's yellow, it means that there might be some lack of overlap. So you should go back and see what's happening there. Another way of checking the real-time onboard automatic registration is going back to the home and going to the registration field or registration app, and you can see all your projects over here and see how they're registering on the scan position. So for example, I had one over here that failed. I can just go back and do another scan or just check what was going on that project. The third QA/QC technique is leveraging the 2D map that delivers real-time access to all scans in the project, showing if or where we are missing data. You can tap on the home button of the scanner, scroll down, and tap on the project map right here, and then you can you put your smartphone or tablet and scan the QR code, and it will give you on your browser this 2D map. You can zoom in and zoom out and even see different levels with color gradient on the map, right? Also, depending on the range of distance you need to scan, you can select the measurement program or the scan pattern, and the one that you will decide for your project or for your scan. You can independently or interchangeably select it inside your project. We typically recommend using higher point density for other projects, like a 6 millimeter a 10 meter range. That's the 25-second scan. Or and for indoor projects, we typically recommend the 8 millimeter at 10 meter for a faster scan. On this example, I'm using scanner for a very long distance project, and that's over 2,000 feet away. And I was just selecting each of these measurement programs, going from the fastest one. Actually, this is the fastest one, going up to 140 kilohertz. And you're gonna see how buildings start appearing, right? So this is the 1200 kilohertz. This is the 600 kilohertz. Now you start seeing the details, and this is the 140 kilohertz. Now you can see actually even cranes behind the main buildings, the main skyline. So you can also have an extra cushion of confidence. You can also perform a high detail scan. Within a scan, you would select a window within your scan, and that will give you areas of maximum density. It will definitely increase the scanning time, but it will also give you impressive level of details of the area you need to focus on. Like, for example, I was focusing on this area, and as you can see, it's all marked green, and this is the product. So you can see conduits, you can see even the bolts that were supposed to be, you're holding the cap on this connection, right? So it is also a great tool that you can use in the field. Another analysis that it's becoming more predominant and more important every day is the floor flatness or the surface analysis tool. So it checks floors, surfaces, verticality, plumpness, deformation, all performed with the 3D laser scanner. It's all within the same software, the RIEGL Pro. So it all starts in the field where you need to take a very high detail scan of a surface to check horizontality or verticality or flatness or smoothness. It is very common nowadays that the use of robotics in manufacturing facilities, for example, or industrial warehouses. And for these robots to best perform, they need to have a very flat and smooth horizontal surface to carry on their duties. Sometimes transporting heavy lifts, or sometimes just placing heavy equipment that needs to lie on a very flat surface. The tolerance can be checked with the VC600i and then post-process it for further analysis. The point here is that the data collected needs to be of the highest quality, and that's what we get with the VC600i. So going with the simplified setups, you can check. I mean, you can always see what you're doing on the scanner on the 7-inch screen that it has on board. You can connect through the app, or you can even connect remotely through Wi-Fi. It's pretty easy to set up. It just takes a couple of seconds and just connecting the scanner through the phone or through Wi-Fi. That's all it takes. So depending on your project, you might or may not need survey controls, right? So in this section, simplified setups, I'm going to be explaining the workflow without control or targets, just real-time automatic registration. It gives you less dependence on targets, meaning simplified logistics, and as well, it's going to be quicker setups. It's more flexible regarding the workflows. All you need to consider is having enough overlap for the cloud-to-cloud registration going on the background or the backend. So you will need spheres. You will need to place checkerboards. That's very time consuming, and you just need to scan and then translate the data to a different coordinate system. The point cloud is, I mean, in the AC industry, architecture, engineering, and construction, specifically for indoor projects, it's very commonly used this way, where you can just go scan, not that many control points, and just translating that point cloud into the project's own coordinate reference system, right? So you after you complete your scan, you basically just take that point cloud and move it to a 3D model like Revit, the software own project coordinate system, and then you can collaborate with the rest of your teams. So this is very used also in manufacturing facilities that just need to clone process areas. They would have a point cloud, and they would move it all around different facilities in different places, and typically like on cookie cutter projects, where you don't need coordinates, but just a fully functional point cloud. So the VC600 allows to scan fast, and it will sequentially register all the scan positions as you go. That's real time, or almost real time for the most riggers in this subject, right? We have talked about that. It only takes a few seconds to register a scan position, and it does it while you're scanning the next scan position. So it's all in the background. It's all, you don't need to do anything. It will do it itself. And that's possibility because it has those two processing units on board, the one that's collecting data and the one that's processing simultaneously. So no targets whatsoever in this method. It will register just by comparing the planes, surfaces. It creates voxels and common points, and that's it. It will do it 100 by itself. So on the other hand, we have that the VC600i is easily portable. So it has the 3-point stand setup. It comes with a carbon fiber lightweight tripod. So moving it from scan position to the next scan position is super easy and convenient. The scanner actually weighs a little bit over 15 pounds, including the 2 hot swappable batteries. And well, I've seen many customers use different setup systems. So I just wanted to share a couple of them and leave it to your imagination to see what else you can do with this versatile scanner. So I know that a few of our customers have mounted it on an ATV vehicle, or very similar like a golf cart, and they scan without even ever leaving the vehicle. They just put on the app, they just open the app, and just driving and then stop and go scan, right? They can do the same with with a dolly, like in this flattening surface. And I actually did it myself. I was in my car and I just put it on top of the roof rack, and I was just scanning. And as you can see, this was scan position number 6, 7, and I did like 40 scan positions that day, and it was fast, convenient, and all in the comfort of inside of my car with AC, with the air conditioning on. So I've seen people mounting on a dolly, which works pretty good. Surfaces with or without a tripod, just like mentioned before. It's super convenient, super easy to move from scan position to scan position. Survey control is key. The scanner does a fantastic job delivering a fully georeferenced project, and you can work with your own project coordinate reference system, or you can georeference your project to an coordinate system integrating externally surveyed control points and validation points, right? So the workflow here is very straightforward. Traditionally, you would have to get you have to set targets and spheres or checkerboards, as you can see over here, all over the place, and you need to see them, typically 3 on each scan, right? So imagine doing 50 scan and having to place all those targets. That takes a lot of time. So our approach here is that you can place just a few targets. Actually, for this project, we use a cylindrical target, this one over here, and we set it up to like every 10 to 15 scans. So on the picture, as you can see, this little flag over here, we set one cylindrical target over here, one in the middle of the bridge, and one at the other side of the river or the other side of the bridge, right? And it was enough for the over 50 scan positions that we did that day on that project. So we recommend those targets to be visible or to scan from 3 positions each. So that would make like 9 scan finding targets on the over 50 scan positions that we did on that project. So that adds up when you are trying to save time, right? Okay, so once you scan those targets and load it into the software over here, the scan targets, you can add your survey control points, your known points, create links between them, and then just let a program, it's called MSA2, finally adjust all the scan positions tightly to the survey control points. And your result will be a fully georeferent and very accurate and precise point cloud. You can do that either, MSA2, you can run it on the post-processing, but the GeoSys manager, you can actually upload it into your scan. So a little bit more about survey control is key. We do know that many industries rely on high quality data for the projects, such as architecture, engineering, transportation, construction, manufacturing, just to name a few. So survey control and data collection is a critical component to utilize site data with exceptional accuracy for downstream value like BIM, BDC workflows, detailed twins, asset documentations, inspections, you name it. Without it, large projects can derail and lead to costly construction errors and or a little bit before the line, misaligned designs, right? So accurate laser scanning data is where it all begins. All these techniques help reduce or even eliminate manual adjustments and ensure compatibility with other data sets such as GIS or GIS, CAD, and BIM, allowing for multiple teams to work and collaborate on your data. Your work and product are essential and a vital piece in the overall project. So here's a quick example in reference about a perfectly aligned point cloud, as you can see, where it's perfectly aligned with the BIM model that you see over there. This is an industrial facility. I'm sure you can imagine different disciplines of engineering teams like working together to create BIM models like civil, structural, mechanical, electrical, etc. To then coordinate and federate those models on your data. So that's something that that we need to understand that our data is going to be used in many processes and tasks, downstream on that project. Georeferencing made simple. So whether it's on its the original configuration with the included GNSS receiver or with the powerful line of accessories that we offer, like this RTK GNSS antenna receiver, the VC600i gives you up to 1 to 2 centimeters absolute positioning accuracy on the vertical of course, by adding your survey control node, you can also reach greater accuracy. Georeferenciation gives teams the simple truth of location in space, right? So it is a universal truth. How many times have you encountered that your georeference point cloud is actually QA/QC survey and validation control points? It happens. I was actually in a conference, and one of the case studies was precisely about that. The survey control points and validation control points can be wrong. It's rare. I mean, rarely it happens, but it happens, right? So that's why the registration, alignment, and georeferencing is a must in all projects. It ensures that all your scans fit together with or without controls, and you can actually place them in a real-world coordinate system. On the scanner, you can, laser scan data with server control not only serve the purpose of delivering consistent and reliable data, it also gives you the confidence that what you're doing is 100% correct, and that your clients can align the data with their defined coordinate systems to match with other deliverables like CAD or BIM that we just mentioned. You can do that by setting a workflow on the scanner or actually after on the post-processing. So you have two ways of doing it. Our systems support these following coordinate systems, like the scanner zone, the project's coordinate reference system, locally labeled, arbitrary, global coordinate systems, and with NAD83 or WGS84 transformation, and many more. Again, that can be done on the scanner, or actually it can be done on the post-processing, which is, I think, it's the easiest way to just go on the GeoSys manager and input your and create your import and export transformation values for your project. Go quicker, go mobile. This is a very fun part because I think this is like this scanner is, this line of products is one of its own. So the mobile capability extends the applications of this scanner to collect larger areas in shorter amounts of time. The current capability is to collect data at up to 50 miles per hour, although I have tested it at 20 miles per hour, and I'll show it in a minute how it looks. And the data, of course, still looks really good. It is, of course, the more speed, the sparser the points. But as you'll see, these the projects they come along very nice. So as you can see over here, we support platforms like a tripod, backpack, this rail system for railroad projects, or putting on top of vehicles for like this pickup truck for city mapping, vegetation, small to medium transportation projects and such. The scanner can be set to rotate while moving, or on model scanning mode, or to a fixed frame to capture just one side of the road or specific areas, right? So this is for example, the first example. This was done in a 15 mile per hour range of speed. This is a small project I did last year. It was on a park near our offices. It took us a little bit more than an hour to complete the whole project, and it included like 40 static scans and 2 mobile rounds on the mobile capability on top of the pickup truck that you just saw. I selected these 2 areas in red to show you a few of the capabilities. So this is a whole project. These on green, you'll see the mobile scan on colorized, and the colorized data, of course, is the scan positions. As you can see, I focused mainly on these areas over here for the static scans, and we drove from here. This black area over here is the pickup truck, and we did 2 rounds going all the way here and going back. So this is one of the questions I've been answered, that I have answered many times. Can we integrate both static and mobile scans? The answer is always yes. We can integrate that those 2 data sets using the same software. It's called RIEGL Pro, and it looks pretty much like this. So do you think that that could help you increase your project volume and capacity? That's a good question. And would that help you scale up your operations? You know, having a quick scan of fair areas or large areas, and then just fine tuning those scans with static scans on the areas that you need more detail. I would say that's a good question. That's a fair question that you need to ask yourself, right? So again, this wasn't 50 miles per hour. We could have walked with a backpack or a dolly, but we wanted to do it at 50 miles per hour because that was the objective of that exercise at that time. So here you can see the detail of that mobile scan. You can see the curves and the gutters are very well defined, and you can even see the cobblestone pavers on the roads. So you also can see the trees, the branches, the trunk, and the sidewalks, and all assets are very clear and very crisp. Look at this stop sign. Look at this vehicle back here. Look at even at the tire. Look at another stop sign over here. Some of the signs back there. This is a corner on the street. So it looks pretty good, right? So let's take a look at how accurate it can get. This is a random section or a profile section on the road, and you can see over here this is grass and this is actually the road, and you see how crisp it gets, how clean that data set looks like. This is just after 1 quick processing with RIEGL Pro. So you can see the curves and gutters. You can even get into more details. I'm going to show that curve over here, and we can even zoom in and see how deep we can go, how much we can zoom in and actually see the accuracy of that point cloud. So you can see over here that it's not actually that the millimetric precision is not just actually feasible with the scanner on the static mode, but also as a mobile as well. As you can see over here, this is a 5 centimeter range. So we are within the millimetric accuracy on the mobile mode, going at 50 miles per hour, scanning on a rotation mode. So of course, you would be the one deciding what's the best approach for your projects, but it's fair to consider this method, right? This is a bigger project. This is I think it was like 130 acres site. This park, and I focused on the central area of this park, just basically going through all these roads over here, as you can see. And I exported a KMC file. KMC, it's a compressed KML file, just to show you how it would look like. I did a full static scan on these areas on top of the vehicle, a couple of scans just with a tripod, and a mobile scan all over these, all the roads just surrounding the area. So it took me like 25 minutes to mobile scan it on the rotating mode. And as you can see over here, this is kind of what it looks to data, right? It's full 3D. That's a quick video that I wanted to show you. As you can see, trees are very well aligned, curves as well. They look pretty good. These over here, these like lines, it's the car moving. So I can create a mask and hide those points. And as you can see, again, this is stop sign, and it's very, very crisp and clear. Data looks amazing. And actually, that was at 20 miles per hour. Still, you can see great results. So, conclusions and remarks. Our work during laser scanning and further deliverables are essential for many design and engineering tasks along a project scope. So it's for construction, and even same for construction, and even more, and even for documenting the construction process, checking tolerances, assessing finishes, and checking layouts and more, right? So accuracy and precision are paramount, but it's not just about delivering excellent product for your clients. It's also about delivering in a timely manner and promptly. Time is a valuable resource, and the fact is that we're always fighting against time. So we need to make shortcuts and improvements to achieve better and faster timelines to stay ahead in the game without compromising quality. We need to be reliable, fast, and efficient to get more projects, and and to keep happier new and recurring clients. So that is our proposal: fast data acquisition, fast data transfer, and fast data processing. That's what we're all about with our terrestrial line. So now I'm opening the floor for questions. Just give me 1 second, please, over here. Okay, so let's change to the Q&A. Okay. So we have, while we are on the Q&A, I did forget to launch our poll. So you should be seeing it. Poll, yeah. I'm launching a poll right now. I wanted to learn a little bit about your processes and see where we are at. I'll share the results in a minute. Okay, so one of the questions is, do the scan targets have to be in 1 or 2 scans? Ideally, one target should be scanned from 3 positions, although at least that's what we recommend, right? But again, you don't have to scan. I mean, all your scans does not have to see the targets. So it's just a few, and then all the scans will align themselves on the post-processing with the automatic registration process. Another question is that, can you register mobile data from the TLS to server control? Yes, it is not a process that we have like on RISCAN at the time, but you can do it. It's a workaround, and we're working on having that solution very soon. Another question is, on the high detail scan, can it be colorized? How precise can it be, and how long does it take? So the high detail scan definitely can be colorized. It's that's done in the post-processing. It can be on the precision side, it can go sub-millimetric. So that is pretty amazing. And how long does it take? Well, it all depends on the area that you select for that high detail scan. But most probably it's going to be like about a minute and a half. But again, it all depends on how big the area that you are high detail scanning. It all depends, right? So can you use this workflow with a VC400? Yes, but we definitely need to take a look into the firmware that you have. It might need to be updated, but we can definitely take a look at that. So please just send me a direct message or an email, and I'll look into it. How fast can RIEGL deliver a new VC600i? Well, at this point, it's probably after a purchase order is placed, probably 2 to 3 weeks, I would say. We can expedite. It all depends on the cases and how fast you need it. Can you change the settings in the project without having to close it and create or create a new one? So I guess that means on the settings like the pulse repetition rate or the measurement system, yes, you can do that on each scan if you want. So you don't have to go out of the project. You can do it on every scan. Okay, so this is pretty interesting. So on the poll, how frequently you add survey and validation control points to your scan data? 60% said all of the time, and 26% said frequently, 3% said 50-50, and 3% said rarely. What are survey control points? That was kind of a joke, but yeah, it's interesting that that many of you are using control points, and if not, that's okay. The scanner will register itself, I mean, all the scans very nicely. So that's great. Okay, so that sums up our webinar. I don't have any more questions here. This is my contact information. I'm in the Miami area, but you know, we travel all over the US and actually abroad. We can do demos for you. We can set virtual and live meetings with you. So don't hesitate to reach out. Thank you very much all for joining me today, and I hope you found this presentation relevant, and look forward to meeting you soon. One last question. I'm doing a high definition scan of tram tunnels at an airport with a VC400i. I have set survey grade control every 200 feet. First scanner had issues trying to intersect 60 millimeter targets, and then during my MSA process, it's not working. Okay, so that definitely it's we can work on that. That's a very specific question. So let's chat privately, and I'll give you all the answers and connect you with our support team. So again, thank you all for joining me, and I hope you have a great rest of your day. If you are going to Industrial Immersive next week in Houston, please stop by our booth. I'll make sure to give you a great welcome. Thank you all.